part 3 of the rational functions task. So the first part was to create an equation using our student number. So I did digits 6, 2, and 8 because they're all factors of 2. I chose an x-intercept at x equals 8, a vertical asymptote at x equals 6, and a whole at x equals 2. So to create the equation, I know right away x-intercept means it has to be in the numerator. So I wrote x minus 8 because if you were to sub back in x is 8, you'd get 8 minus 8, which is 0. A vertical asymptote at x equals 6, so I know that's in the denominator, so I wrote x minus 6. Again, summing it back in, you get 0. A whole at x equals 2, so that has to be in the numerator and denominator, and I wrote x minus 2 in both, because then when it crosses off, you get a whole. Then to find my graph, I found key points, so I started off by finding the y-intercept, which I did, I subbed in the x for 0 and into my equation, and I just solved to get 4 over 3. So my point on my y-intercept is when x is 0, y is 4 over 3. So I plotted that right there. Then I sketched my vertical asymptote, and then I sketched also my horizontal asymptote, which I found from my equation. Since I know my degree is the same, then I just take the coefficient of the highest degree, which is 1, and you just get 1 over 1, which is horizontal asymptote is equal y equals 1. So I sketched that right there. Y is 1. I also plotted my x-intercept that I already found, so 8. So in y is 0, x is 8. I also made sure to put a point right here, open circle though, for my whole, so when x is 2. And just to check on what y value that is, I subbed in x for 2 in my equation, and I got 1.5. So I sketched that about right there. And then the rest, you could freehand the graph, or you could just check, since you already know that the graph has to be in this section and this section, because there's a vertical asymptote and a horizontal asymptote, so it can never cross on this side or this side. But just to check, I found the end behaviors to take this method where I take the vertical asymptote and I take values really close to both the right side and the left side. So for the right side, I took values like 6.0001, which is really close to the vertical asymptote, and I subbed it back into the equation to get a really small value, so negative infinity. So it tells me that it goes downwards. And then for the left side, I subbed in a value also, again, really close, so it's 5.99 repeating. And then I sub that back into the equation. You get a really big number, so positive infinity, so you know it goes up. And then you could just freehand the rest of the graph. And then the second part, what I did was, it was to solve this equation right here. So I know that I have to move this expression to the left side to get it bigger than or equal to 0. And then when I have this subtraction, I realized that I have to do the common denominator. So I did x plus 5 multiplied to this expression, and then x plus 6 multiplied to this expression, which I showed right here. And then I did distributive property because I wanted to multiply 2 times x, 2 times 5, 2 times x, negative x times x, and then negative x times 5, and then the same on this side. I also then, in this step, I just opened it up, and then I collected the like terms here. Then I multiplied the negative to every value because you have to make sure this turns into positive, this turns into negative. And then in this step, I collected again all like terms. Again, it's all over the denominator of x plus 5 and then x plus 6, all bigger than or equal to 0, still the same thing. Then I got negative 2x minus 4 over x plus 5 bracket x plus 6 has to be bigger than or equal to 0. I realized that I could factor this negative 2 out, so I did. And then with this final solution, you have your 0 given to you, which is x equals negative 2. And then your two vertical asymptotes, which are negative 5 and negative 6. So with this information, you could use this interval chart. And I noticed that my intervals, it goes from negative infinity to negative 6. So that's all circle brackets because vertical asymptote never touches it, so its circle bracket does not include. Negative 6 to negative 5, again, circle brackets does not include. Negative 5 to negative 2, square bracket because 0 does include because it crosses the x-axis. And then negative 2 square bracket, and negative 2 square bracket to infinity. And then I chose values in each interval. I subbed them back into these this equation. And then I found my final sign. So I know when it says bigger than or equal to 0, it has to be positive. So I know it's this interval and this interval. So my final answer is f at x is bigger than or equal to 0 at intervals negative infinity to negative 6, circle bracket to negative 5 to negative 2, the square bracket. And that is my final answer. This is my overall solution, just so you could see.